Hello guys, how are you? It's teacher Jolanda here. Welcome to our session 24. For this session we're going to continue with science. So please get your content areas notebook, your reading project and your reading project exercises, and let's begin. The text that we're going to read today is called Our Solar System and it's in your reading project book. Introduction. Our solar system is made up of the Sun, 8 official planets, several dwarf planets, and hundreds of planetary satellites or moons. It also contains comets, asteroids, and clouds of gas. The Sun is the center of the solar system. Everything else in the solar system goes around or orbits the Sun. Mercury, Venus, Earth, and Mars are the inner rocky planets. They are made of hard materials. The outer planets are Jupiter, Saturn, Uranus, and Neptune. They are known as the gas giants and are made mostly of gases. The outer planets are hundreds of times larger than Earth. To get an idea of the size of things in our solar system, imagine that Earth is a grape. If the Earth were the size of a grape, the Moon would be the size of a green pea. The Sun would be as big as a ball that an adult man could stand in. Jupiter, the largest planet, would be the size of a grapefruit, while Saturn, the second largest planet, would be the size of an orange. Uranus and Neptune would be the size of lemons. So, here in the picture we can see an approximate size of Earth for comparison. The Sun is just huge. Let's read this information over here. The diameter of Earth is approximately 13,000 kilometers or 8,100 miles. The Sun's diameter is approximately 1.4 million kilometers, that is 870,000 miles. How many times larger is the Sun's diameter than the Earth's? Okay, let's do some maths and tell me later in our class. The temperature of the Sun's surface is about 6,000 degrees Celsius or 10,832 degrees Fahrenheit. The Sun's core, the core is the center. The Sun's core is approximately 15 million degrees Celsius or 27,032 degrees Fahrenheit. So that's extremely hot. Let's continue reading the text. The Sun. The Sun is a huge ball of burning gas that sends energy far out into the solar system. The Sun plays a very important part in our daily lives, providing energy that supports all life on Earth. The Sun causes seasons, climate, ocean currents, air circulation, and weather. Without the Sun's energy, plants could not grow and make food. Also, there would be no gas, oil, or coal, which are the Earth's fossil fuels. Fossil fuels are formed over millions of years from dead plant and animal life. The Sun is just one of billions of stars. It has been around for about 4.6 billion years. It will keep producing energy for another 5 billion years. Before it dies, it will swell up and swallow many of the inner planets. Then it will shrink into a much smaller ball. So what is swell up? Swell up is inflamarse. So before it dies, the Sun will become bigger and maybe make all the planets disappear. And after that, it will become smaller. So here it says relative sizes of the objects in our solar system. Look at that, Mercury is barely visible. And here we've got Pluto and Mercury, look as small as that. And look at our Earth, it's almost nothing compared to the Sun. We're reading here. This picture shows a close-up image from the NASA Discovery flight in 2008. Shows a huge glorious impact basin on Mercury. Mercury, Mercury is the closest planet to the Sun. It is the smallest planet in our solar system. It takes only 88 Earth days for Mercury to make a complete orbit around the Sun. For comparison, it takes Earth 365 days or 1 year to orbit the Sun. Like all other planets, Mercury spins like a top as it goes around the Sun. It spins very slowly. Each spin of a planet is a day on that planet. A day on Mercury is 59 times longer than an Earth day, because Mercury spins or rotates so slowly it gets very hot during the day and very cold at night. In addition to having air too heavy to breathe, scientists found that Venus rotates backward. This means that on Venus the Sun rises in the west and sets in the east. The colors used on this Magellan mission image represent different elevations on the surface of Venus. Venus. Venus and Earth are similar in size, but Earth and Venus are very different. Venus is covered by layers of clouds that are much thicker than clouds on Earth. These clouds trap most of the sun's heat. The temperature on Venus gets very, very hot, more than 4 times hotter than boiling water. As well as trapping in heat, the clouds of Venus reflect sunlight. This makes Venus one of the brightest objects in the sky. The air pressure on Venus is 90 times greater than that on Earth. For this reason, space probes that land on Venus stop working within a few hours. Venus rotates even more slowly than Mercury. 1 day on Venus is equal to 243 Earth days. Let's read this part. Mount Mons, a volcano on Venus, is 8 kilometers or 5 miles high. It is very similar to the types of volcanoes found in Hawaii. Earth. Earth is a very special planet because it is our home and also because it is the only planet in our solar system that can support life. The most important difference between Earth and other planets is the abundance of liquid water. Water covers nearly 70% of the Earth. Earth rotates about once every 24 hours, 1 day. It completes one orbit of the Sun about once every 365 days, 1 year. Earth's atmosphere is made up of gases that living things need to stay alive. The atmosphere protects us from most of the Sun's harmful rays. It also helps to protect us from meteors by causing them to burn up before reaching the Earth's surface. Earth has one natural satellite, the Moon. Do you know? Earth's atmosphere is very thin. If Earth were an apple, the atmosphere would only be as thick as the apple's skin. Remember our class from yesterday? That's why we have another layer protecting us, the magnetosphere. The atmosphere protects us from the rays. It protects us from the light. But the magnetosphere protects us from the sun wind or the solar wind. The Moon. The Moon is about 1/4 the size of Earth. It reflects light from the Sun onto us. Many scientists believe the Moon was originally a part of Earth and was broken off in an enormous space collision. Tests have shown that there is water ice on the Moon's surface. Earth's ocean tides are caused by the gravitational pull of the Moon. So yes, gravity is not only something that the Sun gives us, also the Moon causes a little bit of gravity towards us. But it doesn't affect us as much as the Sun. That's why we translate around the Sun and not around the Moon, because the Moon is smaller. Remember, the bigger the body, the more mass it has, and the bigger the gravity there is to that object. So, the gravity that the Moon gives us is what causes the ocean tides. Here it is. Ocean tides. And what's the meaning of ocean tides? That is la marea del mar. Mars. Mars is the fourth planet from the Sun. It is known as the red planet because of large amounts of rust-colored dust on its surface. Mars is the most Earth-like of all the planets of our solar system. Mars has seasons similar to our own, and the soil there is very similar to the soil on Earth, but there is very little oxygen or water vapor in Mars's atmosphere. The climate on Mars changes widely between seasons. Temperatures on its surface can range from 30 degrees Celsius or 86 degrees Fahrenheit in the summer to minus 130 degrees Celsius or minus 202 Fahrenheit degrees in the winter. Jupiter and its moon. In the illustration, look, here's the moon. Jupiter and its moon, Ganymede, photographed on April the 9th, 2007 by the Hubble Space Telescope. Jupiter. Jupiter is the largest planet in our solar system. It is like a star in many ways because it is made up mostly of gas clouds. The clouds of Jupiter form bands that have very high winds and are always very stormy. One gigantic storm rotates counterclockwise at a constant speed of 360 kilometers per hour or 225 miles per hour and acts much like a hurricane. It's called the Great Red Spot. Easily visible, it can be as wide as 3 times the size of Earth. Jupiter's temperature is very cold at the tops of the clouds. At its core is hotter than the surface of the Sun. That's some interesting information. So it is very cold on the outside, but it is actually extremely hot in the inside. Most of it is gas, and what we can see here in the illustration, it's actually a hurricane. A hurricane so big that sometimes it's 3 times the size of Earth. In some ways, Jupiter is like a mini solar system because it is so big and has 4 large moons and dozens of smaller moons orbiting around it. It also has several thin rings at its equator. Scientists believe that if Jupiter had become larger during its development, it could have become a star instead of a planet. Jupiter spins quite fast for such a large planet. One day on Jupiter is roughly 10 hours. It takes Jupiter almost 12 Earth years to complete its orbit around the Sun. Jupiter's constant dust storm, the big red spot, is highly visible, shown in their approximate size in relationship to Jupiter's 4 moons, are named top to bottom: Io, Europa, Ganymede, and Callisto. So pay attention, the storm is even bigger than the moons. Saturn's spectacular rings are mostly made of water ice. Each ring averages about 30 feet in depth, but some bumps and points are more than 2 miles high. Saturn. Saturn is the 6th planet of the solar system. It is easy to recognize because of its large, visible system of rings. The rings are made up of millions of pieces of ice and frozen gases. Saturn also has dozens of small moons that orbit it. So, here pay attention. It is visible system of rings. Why do you think they make such an emphasis that the system of rings is visible? Because other planets have rings, but they are invisible to our eyes. Saturn is also unique for another reason. It weighs little compared to how large it is. Saturn would float if a swimming pool could be made big enough to hold it. Saturn spins very fast, making one day on Saturn 10.5 hours long. 4 moons of Saturn passed in front of the planet in the illustration. Enceladus and Dione on the far left cast shadows, while the larger Titan and the small Mimas at the far right do not. So all of these are tiny moons. Some of them not so tiny. Some of Uranus' moons and rings can be seen clearly in this Hubble telescope image. The bright spots on the far right of the planet are high clouds. So pay attention, Uranus also has rings, but sometimes they are not quite visible to our eye because we cannot see those gases. Uranus is the seventh planet of the solar system and the third largest. It looks blue-green in color because of the methane gas in its atmosphere. Uranus seems to roll around the Sun because it is very tilted. Scientists think this might be because it bumped into another planet-sized object long ago. Uranus has at least 27 moons, 5 of which are large. Scientists have also counted at least 13 rings. It takes Uranus 81 Earth years to go round the Sun. Toward the top is a backward storm that scientists have named Dark Spot 1, and lower is Dark Spot 2. The cyclone-like winds spin counter to the direction of Neptune's orbit. Neptune is the 8th planet from the Sun. Neptune and Uranus are sometimes called the twin giants because they are so much alike. They are about the same size and color, and both are covered with thick clouds. But Neptune's winds are the fastest in the solar system, reaching 2,000 kilometers per hour, over 1,242 miles per hour. Neptune has one large moon and many smaller moons, plus several visible dust rings. It takes Neptune about 165 Earth years to go round the Sun. So again, Neptune also has rings. Pluto and other dwarf planets. What is dwarf? Dwarf is enano, planetas enanos. Before 2006, the space object called Pluto was the 9th planet of our solar system, but scientists debated and voted to create a new category called dwarf planets for space objects like Pluto. Dwarf planets orbit the Sun, have nearly round shapes, produce a minimum level of brightness, and are not moons. They also do not have enough gravitational pull to sweep other space objects from their orbit. Scientists began by identifying 6 official dwarf planets, but some scientists want to classify dozens of similar space objects as dwarf planets. Many more space objects could be counted among dwarf planets as technology makes it easier to identify them. So, that means that there are lots of dwarf planets. We're going to talk about that in a few minutes. Now let's pay attention to this rectangle. It says, what will you weigh? Gravity is different on each planet, and gravity determines how much you weigh. If you weigh 70 pounds on Earth, then you would weigh on Mercury 27, Venus 63, on the Moon 12, Mars 27, Jupiter 165, and Saturn 65, Uranus 62, 79 on Neptune, and 5 on Pluto. In outer space, you weigh nothing. So, what's that? That means that gravity depends also on the size of the planet. Satellites monitor impact tests during research into ways to prevent asteroids from colliding with Earth. Asteroids. Asteroids are rocky, metallic objects orbiting the Sun. They range in size from a few feet in diameter to hundreds of miles in diameter. Most asteroids are found between Mars and Jupiter. Some have orbits that cross the Earth's path, and in the past, some have even crashed into Earth. Asteroids and other smaller objects that enter Earth's atmosphere are called meteoroids. If they survive the trip, and land on the ground, they're called meteorites. If they burn up before landing, they are called meteors. Among the best evidence of an asteroid hitting Earth is the Barringer crater near Winslow, Arizona. The comet NEAT, photographed by the WIYN telescope at Kitt Peak National Observatory in Arizona, was discovered in 2001 by the Near-Earth Asteroid Tracking System. Comets. Comets are composed of ice and dust and are like large dirty snowballs in space. They have very oval-shaped orbits. For part of that orbit, they come close to the Sun, and then they swing far out into space. Some comets orbit the Sun in less than 200 years. The most famous of these is Halley's Comet. It returns every 76 years. Other comets take thousands of years to complete an orbit. Comet Hyakutake, which passed close to Earth in 1996, will return in about 9,000 years. Conclusion. Humans have always wondered what's happening out there in space. For centuries we could only guess. New rockets, space probes, satellites and telescopes show us what's happening in our solar system every day. These tools have helped scientists to discover new planets, recount moons, and see stars being born and being swallowed. They have also given us the first full sky survey map of our universe in a direct view at the Sun. What will they show us next about our solar system and beyond? In July 2010, after a year-long mapping mission, the Orbiting Planck telescope of the European Space Agency ESA delivered its first full sky survey of our universe. Planck's mission is to measure radiation left over from the ancient beginnings of our universe so that scientists can study how it was formed. As Planck sweeps the sky, it also measures the temperatures, density of matter, speed and movement of galaxies. So, this is very interesting, isn't it? We know more or less some new things about our solar system. But if we paid attention at the beginning, it said that our solar system was made up of one enormous star, the Sun, 8 official planets, lots of dwarf planets, clouds of gas, asteroids, meteors, meteoroids, or also comets. But what is the collocation of all of them? What is the original position of the universe? This book is very good, and it's in some ways more or less similar to your set books about science. But there's much more to study about this. So, let's talk about the extended version of the solar system. This is a real thing now. We're talking about more elements in our solar system. Most of our science books that we have in our school will end here. And that would be the end of it. And they would leave all of this area outside. So, let's study. What is that? As we can see, we have all of our planets. We have Mercury, Venus, Earth and the Moon, Mars, and 2 moons, Phobos and Deimos, the asteroid belt. In the asteroid belt, we have many asteroids that are even bigger than the Moon. One of those asteroids, and maybe the most famous one, is Ceres. Then we have Jupiter with one of its storms, and Jupiter has lots of moons, and many of them are so big as Mercury. Then we have Saturn, the same, with lots of moons and the rings. Remember that Uranus and Neptune also have rings, but most of them are made of water ice. And here we have lots of moons that they have. And after Neptune, we have another belt. Here we know that we have the asteroid belt, but actually there is another belt in our solar system. The new belt is called Kuiper belt. Again, Kuiper. It's in honor to the person who discovered this belt, the Kuiper belt. And all of the objects that are around here, they are called the trans-Neptunian objects. In here is where we have Pluto. Look, this is Pluto. But guess what? There are some dwarf planets, if you want to call them that way, which are even bigger than Pluto. And that one is Eris. Eris is bigger than Pluto. And recently, some scientists have decided to take Pluto back into the planet classification. But let's be honest, if Pluto is a planet, then Eris must be a planet because Eris is bigger than Pluto. And all of these are planetoids or dwarf planets or planets which are in the Kuiper belt. After that, look at that. What is that? That is a comet. So now we know where comets come from. Most of the comets in our solar system come from a cloud. This cloud is called the Oort cloud. In the Oort cloud, we also have an enormous planet that is called Sedna. And we have many others, but Sedna is the biggest one. And in the cloud, we have icy objects and gases compressed into rocks. So whenever solar wind travels across the solar system and it catches some of the things in the Oort cloud, they start making an explosion. And as they make an explosion, they transform into comets and they start going around like crazy in the solar system around the sun until they go out of the gravitational pull of the sun. Here I found another scheme of our solar system, which is more accurate. What is accurate? Más exacto. Again, here in the asteroid belt, we can see Ceres, which I told you was bigger than many other planetoids. Look, here is an aurora in Saturn, and we can see how big its moons are. Here we can see the belts or rings around Uranus and Neptune. Can you see them? And here in the Kuiper belt, we have all of the objects. We have Pluto, one of the planets, Ixion, one of the planets, Orcus, Haumea, Quasar, Varuna, Makemake, Eris, and Sedna is more like in the Oort cloud. And here we have comets already igniting and going around the sun. Here I have some of the Kuiper belt objects. For comparison, we have the moon. Triton is a moon in Neptune. It's a moon of Neptune. And after that we have Eris. Eris has one satellite, Dysnomia. Pluto, which has these moons, Charon, Hydra, Nix, Makemake. Haumea, which is more like an egg-shaped dwarf planet and its moons. Sedna, which I told you was closer to the Oort cloud, and Quasar with its moon. Astronomers continue to find sizable objects in the Kuiper belt. This illustration shows some of the largest known bodies, including Neptune's captured moon Triton. The Earth's moon has been included to give an indication of the size of the object. So this is obviously not in the Kuiper belt. It's orbiting around our planet. So it is so you can more or less check the size of these objects. Now, let's talk about this. As I was telling you, this would be mass. In here, we would have the asteroid belt. And after that, we will have the Kuiper belt. The Kuiper belt is after Neptune. And then there will be some space. Look, some space here. This is the Kuiper belt. There will be some space, and around that, all around, we have an enormous cloud, the Oort cloud, which contains gases and rocks made of gases compressed. Remember, all of these things are what, when ignited by the solar wind, they become comets. So, imagine the Oort cloud like an enormous sphere around the solar system. This is the planetary region, so small. Then we would have the Kuiper belt. The Kuiper belt is actually bigger than all the planet's space. After that, there is a smaller space, and we would have the Oort cloud, which is enormous. And all of this is the cometary nuclei. What is the cometary nuclei? All of these things can become comets. We just need them to be reached out by the solar wind. Let's talk about the sun. The sun also has some sort of layers. As we have the ozone layer or the magnetosphere, the sun's powerful rays also have some limits. Of course, the closer it is to an object, the more dangerous, but it becomes weaker as further it gets. So let's see. This is the sun and these are our planets. All the solar wind can reach the complete planets easily. After that, we would have a termination shock. Starting here, the rays and the solar wind become weaker. After that, we would have the heliosheath. After that, we will have the heliopause. And after the heliopause, we would have the bow shock. That is the end of all radiation emitted from the sun. A long time ago, in the 70s, two space probes were launched in space, Voyager 1 and Voyager 2. Voyager 1 and Voyager 2 were launched from our planet, the Earth, into the space. They reached Jupiter, Saturn, and they sent photos back to Earth. The first photographs of these planets were taken by the Voyagers. But guess what? Right now, the space probes are here, already breaking the heliopause, and they are about to leave all the gravity and all the power of the sun. Too bad they are not working very well, but well, they were launched in the 70s. So last but not least, remember to check the PDF with all the exercises that we have to have done before the class, and I'll see you in a few minutes, okay? So bye!